All right, welcome back. Math from the void. Math hitting you out of nowhere. And today we are going to make use of the chart. If you have not already looked at my video for the chart, or if you're not already familiar with the chart, that is capital T-H-E. Oh, let's zoom in a little bit. That is capital T-H-E, the, or you can say the chart. It's not just a chart, it's the chart. It's the one that's going to save you for pretty much the rest of your mathematics career whenever you have to determine positive and negative values of a function. Or I guess I should say when you need to determine intervals on which a function is positively or negatively valued. That's the better way to say it. Anyway, enough word salad. Let's go to what we're looking at today. We're looking at the rational function. And this is really leaning into what was emphasized on the chart, because in the chart video that I have, if you haven't already checked that out, please check it out. I use a rational function as one of the examples to demonstrate how useful the chart really is and how it works and all these things. Now, if you're in an Algebra 2 class, you may or may not have already approached this unit of rational functions. There are many features of rational functions. Most of these word problems are sort of longer multi-part problems with rational functions. They'll have several parts like this, and they'll ask you for several different features. So I want to take the time to break down each of these features. What you want to be able to do before you can even approach an object like this is you need to be able to factor. All right, so consider the possibility that these can factor, and you should be able to identify quite early that this is a difference of squares. So we can rewrite that as, let's say, x minus 2 and x plus 2. Because these rational functions sometimes have holes, determine the x and y coordinate of any holes. There isn't necessarily going to be holes, but if they say something like this, it's kind of suggesting that there could be a hole. So a reminder that we get a hole in a rational function whenever there's a factor which cancels on the top and bottom, so a common factor in the numerator and denominator. So that kind of gives us a clue that one of the factors on top might be x minus 2, or it might be x plus 2. This one's not too hard to factor, and there are different methods for factoring this kind of expression. If you're not familiar with that, get familiar with it. I probably have a video about it, but honestly, at this point, like factoring a quadratic, bro, you got to be able to do it. I think it's pretty obvious that one of these is going to have 2x on it, and one of these is just going to have x on it. And then they need to multiply, or when I say they, I mean these two numbers here that we don't know yet. Those two numbers need to multiply to make negative 2. So one of them needs to be a 1, one of them needs to be a 2, one of them needs to be positive, one of them needs to be negative. We're not sure where they go. It could be negative 1 and plus 2. It could be negative 2 and plus 1. But like I said, we should probably take the clue that there's going to be x minus 2 or x plus 2 as one of the factors. So let's first try with x plus 2. Let's see how that goes. If that's the case, then this has to be a minus 1. And if we do the FOIL process, if we multiply these, I do the inner, which gives me negative x, and then I do the outer, which gives me positive 4x. Those are not going to combine to make negative x, so that's not the right combination of numbers. Okay, so you should give it a shot, see if you can figure out what values go here. And it's not necessarily true that there has to be one of these factors up there. I'm just saying that it's worth considering. It's something you should kind of always consider. Let's see, it looks like we're going to need a negative 1 here. Or maybe this doesn't even factor over the reals. That would be very interesting. It's possible that this doesn't factor. Let's see, negative 1 and a plus 2 here. Okay, that doesn't seem to work. So let's try negative, or rather positive 1. Oh, yeah, no, I don't think this factors, guys. I didn't check this beforehand, so I really am not too sure. One way that you can tell if it factors over the reals or not, or over the integers, is by using the discriminant, b squared minus 4ac, where this is your a value, negative 1 is your b value, and negative 2 is your c value. So this would give us 1 minus 4 times 2 times negative 2, which is going to give us 1 plus 16. This is going to give us 17. Now, because it's not a perfect square, when we look at the quadratic formula, that's not going to give us a whole number. So it turns out, ladies and gents, we do not have any factors on the top. All right. It took a little while to sort that out, but it is very important to sort out whether or not you can factor the top or not. Okay, so let's get started with this. Now that we have a general idea of what's going on, we've broken down our numerator and denominator as much as possible anyways. Then we're going to take a look at these parts of questions. So first part is equation of the horizontal asymptote. Horizontal is a flat line, kind of like the line that I'm using to underline the word horizontal. And so it has a 0 slope. This is going to be in the form of y equals something. And if you don't remember how to analyze this for a horizontal asymptote, we need to consider the ratio. Well, first we need to consider the degree on top and bottom, but the highest exponent, which is the degree, is the same. And therefore the numerator and denominator are sort of growing at the same speed. So we look at the coefficients now. We have a 2 in front and a 1 in front, even though you don't see the 1. Therefore, the ratio is 2 over 1. And we get a horizontal asymptote of 2. What that means is that when x values get really large, whoa, let's make this quite a bit bigger. When x values get really large, the fraction approaches, it's never quite equal to 2, but it approaches 2. And that's why we call it an asymptote, because it doesn't actually get there, but the 2 is sort of like a boundary line. Next, we want to write the equation of any vertical asymptotes. Now, a vertical line, of course, a vertical asymptote is going to be a line that goes up and down. And so these are going to be x equals equations. I say equations because there are 2 of them in this case. The vertical asymptotes are values for which the denominator only is equal to 0. What do I mean only? The denominator only, not the numerator. So we're going to look at x equals 2. That will make the denominator 0 since it's one of the factors. And then we're going to look at x equals negative 2 because that is also going to cause the denominator to be 0. You do need to check to make sure that that's not going to cause a 0 up top. I've sort of already done that mentally. So if you plug in 2 times 2 squared minus 2, basically just replace these x's with a 2. That's going to give us 8 minus 2, so that's not a 0. And then if we plug in negative 2, it's still going to give us 8, and then plus 2 minus 2, not going to give us a 0. So we know that there's no canceling of the top and bottom, and what that means is that there are no holes. No holes. All right. Because we don't have a common factor on the top and bottom that are canceling. In fact, the top isn't really factorable in the rational numbers. Find the X and Y intercepts. This is such an underrated skill. Like, it's not even funny. There's so many folks who seem to forget that X and Y intercepts are very useful. Not only are they useful, they're usually pretty easy to find. They're generally very easy to find. And the easiest one, hands down, that we should do first is the Y-intercept. The easiest thing to do for a Y-intercept, as we've discussed in an earlier part of this calc prep assignment, I don't know if it was part 2, I believe it was part 2, you find Y-intercepts by making x equals 0. And that's really easy to do. If we plug in 0, go ahead and plug in 0 to the function. You're going to have 2 times 0 squared minus 0 minus 2 over, what did we have? You could plug it into the x squared minus 4 and you just get 0 squared minus 4. But I'm going to plug it into the factored form. And then we're going to have 0 minus 0 minus 2. So negative 2 over negative 2 times positive 2 is negative 4. Therefore, our y-intercept is 1/2. Now, for the x-intercepts, because it doesn't factor nicely in the numerator, it's going to be a little bit tougher. We're going to want to use the quadratic equation. So remember that y equals 0. Why are we just looking at the numerator, by the way? Just a reminder, if we have a fraction f of x equals something with an x on top and then something with an x on bottom. This whole fraction is only going to equal 0 when the numerator equals 0. In fact, I have a video on fractions if you haven't checked that out. I just use a very simple analogy of cookies and people. If you want to know how many cookies each person gets, these are your cookies and these are your people. The only time we would have 0 cookies per person is if we have 0 cookies to start with. Even if we just have 1 cookie in a million people, everyone's still going to get a little bit of it. But if we want this entire fraction to be equal to 0, then the numerator must be 0. So we're just setting the numerator equal to 0. That's 2x squared minus x minus 2 equals 0. And because we kind of try to fiddle with it a little bit, factoring, and it didn't work, we can go ahead and use the quadratic equation. So our X-Intercepts, there will be 2 of them, I believe, is going to be, you got to know the quadratic formula. I'm going to write it out for you here in case you don't. But if you do not have the quadratic formula memorized right now, if you were in a big classroom of a lot of people, you should be embarrassed. But since you're just like at home watching this wherever, you can be embarrassed by yourself, and no one else is gonna laugh at you, I promise. But you get it together. Like get that formula memorized ASAP. Like, dude, ASAP. Okay, so this is gonna be, we have to be careful here because the A value is 2, the B value is -1, and the C value is -2. Just because there's a negative here doesn't mean it already covered the negative. It means we need to do negative of the B value, which is going to be a +1, because a negative 1 is +1. Don't have to explain that too much. Okay, we already did this discriminant part. We did the thing inside of the square root. If you work that out, you're going to get 17, and this is over 2 times A, which is 4. So we have 2 X-intercepts. One of them is 1 plus the square root of 17 all over 4, which is like 1.25, maybe it's like 1.3 or something like that. And then we're going to have 1 minus the square root of 17 over 4, comma 0. And this is going to be like, I don't know, negative 0.72 or something. I don't know, something like that. The actual values, the decimal approximation, I mean, is not that important. But if you want to, you can plug it into a calculator. I'll say this is like about 1.20. And I'll say this is about negative 0.72. I don't know what it actually is. I'm just, ballparking it with my brain, but that's approximately where it's at. Just so that when we sketch the graph, we have decent ballpark of where it should be. Okay, we got the X and Y intercepts, everybody. Now, this specifically says no calculator except for the range in part E. If you're in calculus, do this without a calculator. I want you to find the range without a calculator, and it's going to take much more work than some of my Algebra 2 or pre-calculus students, guaranteed, because you're going to have to take a derivative, find your maximums, minimums, that kind of thing. You know what I'm talking about if you're in calculus. If you're not in calculus, don't worry about it. But if you are in calculus, specifically if you're training for the AP exam, like if you're in AP calculus, you need to be able to do this without a calculator. And if you get values that are like square roots and stuff, that's totally fine. It's okay. I don't expect you to find out what the decimal versions are, but I expect you to be able to do it and answer it with like square roots maybe. Let's talk about the domain. Well, the domain's pretty simple. It's a fraction. It's a rational function. So we just want the denominator does not equal 0, which means we need x cannot equal 2 and x cannot equal -2. Now that's perfectly acceptable in my opinion for writing the domain, but if you want to think about it in interval notation, which uses like a number line, and here's our -2, here's our 2, much like the chart, we'll have zeros right there, and so we're excluding those values. Right, so we're going from negative, the domain would be from -infinity to -2, and then there'd be like a little blip, a little pause. We're going to union from -2 to 2, and then there's another little blip, a little pause, and then we're going to go from 2 to infinity. So that is the domain. The range, if you're interested in using a calculator, that's fine. I'm not going to spend my time to use a calculator during this assignment. I'm really not. So we'll have the domain, and then we'll have the range. We'll take a look at what the graph looks like in a second by using the chart. So find a few key points and graph the function. So now it's time to use the chart. How are we supposed to use the chart if it's not factored, though? Oh dear. Well, here's what I want you to realize. We're going to extend. If you haven't already watched the video on the chart, that's fine. But you might get a little confused here. Even if you have watched the video on the chart, the following might be a little bit confusing. So we're going to look at just the numerator. And in fact, I'll call it a different function. I'll call it like g of x or something. Something that represents in the numerator. Well, yeah, let's do it here. So let's say g of x equals 2x squared minus x minus 2. We know a couple things about this now that we've analyzed it. We know that it's a quadratic, right, because it's squared. Therefore, its graph is going to look something like happy face or sad face. And in this case, it's going to be a happy face because we have a positive coefficient here. So what that means is that it's going to be going through the graph twice. And I did kind of mention roughly where that's going to happen. I said that it's going to happen approximately at 1.2 on the positive side. It's going to happen at about negative 0.72 on the negative side. But really, I want to analyze this so that I can put the values on a chart. Right? So here's how I'm going to start my chart. I'll extend it downwards to include some of the denominator factors. But for now, I'm just going to look at the top, the numerator. And I know that it's going to have some zeros at, well, maybe I can call this 1.2, but maybe I'd rather call it 1 plus root 17. One plus root 17 over 4. And then we're going to have 1 minus root 17 over 4. And maybe I should move these a little bit, or maybe I can just make them a little bit smaller. There we go. And so if we're looking at the other value, oh, this is 0, this is 0. And if we're paying attention to the chart, or to the graph, we see that the graph is positive on the left side. Then it goes negative down here in between. Then it hits the 0 and goes positive again. And in the denominator, I'll just abbreviate it as denom, not demon. Denom, these two factors, the x minus 2 factor and the x plus 2 factor. Now those are going to have zeros as well. And since this is approximately 1.2, we're going to put 2 out here, and we're going to put negative 2 out here since this is approximately negative 0.72. I'm sticking with the negative 0.72. I don't know that that's like a really good approximation for this value, but I don't feel like checking, so that's fine. All right, let's put our zeros on the rows. Now this factor is going to be 0 when x equals 2. It's going to be negative whenever it's less, and it's going to be positive whenever it's more. And then for the bottom factor, we have it be 0 at negative 2, and it's negative when it's less than that, and it's positive when it's more than that. So overall, we have to be careful because these denominator factors will indicate some vertical asymptotes. Whenever these are equal to 0, which is right here and right here, the overall function f of x, which is like the combination of all of these things, it's the quotient of 2x squared minus x minus 2, and these factors down here, x minus 2x plus 2, or just x squared minus 4, the way that it was originally written. These are going to give us undefined values because those represent zeros in the denominator. And they also match up and line up with our vertical asymptotes that we were looking at just now. Right? So let's take a look here. What are the signs going to be? We have positive times negative, that's positive. and then 0 on the denominator, which is undefined here. That's why these bars, maybe I use red for the minus sign, so maybe I'll just use these black lines for the bars. Undefined bars. Then we have a 0 when the top is 0, and another 0 when the top is 0. Let's look what's happening in between. We have positive, negative, positive, so that's overall going to make a negative. Then we have negative times a positive. That gives us overall positive. And then in between here, again, we have positive times positive, which gives us negative. Okay, very good, very good. And then this 0 here produces an asymptote. So we have the bars, and then we have positive, positive. So we can start to sketch the graph. We can start to sketch what it looks like. We know that it has asymptotes at plus and minus 2. Let's indicate that on the graph. Where's the graph? There we go. I guess I'll use red for that. Very thin asymptotes. Okay. We have some points where we think the zeros would be. So that's going to be like 1.2-ish. I'll put that like, I don't know, right here. If it's kind of close to 1.5, that's fine, just as long as it's not on 1. And then a little bit less than, or I guess I should say a little bit greater than -1. What I mean by less is like a little bit closer to 0 from -1, negative 0.7-ish. So there we go. We have this like quadratic kind of thing going on in the middle. And then we have the Y-intercept, which is also an important point to remind yourselves. What was the Y-intercept? I believe it was -1/2, but it could have been +1/2. Yeah, I guess it was +1/2. So that would be something like, this is going to be a 1, so it'd be something like right around there, right about there. I don't know that this thing is symmetric for sure. Like I said, if you're a calculus student, I expect you to be able to find the maximum and minimum. But if you're at a lower level, the expectation isn't quite as extreme. Now let's make sure that this matches up with our sine chart, because it seems to me like the shape would do something like this. Like it's going to make like a parabola going downwards. That's what it looks like to me. We also probably want to draw our horizontal asymptote, which is at +2, y equals +2. So on the endpoints, it's like not going to surpass those boundaries right there. Let's take a look at the chart again. I could just bring the chart over. In fact, I think that's what I'm going to do. I will bring chart and accompanying diagram over, so that we can investigate this a little bit more closely. Where should we investigate this? We're going to investigate this right here. I'm going to put it in the way of questions G and H. We'll just do G and H on the other side, but I want this thing a little closer to the graph so I can constantly reference it. Well, according to this, it is positive all the way up into the asymptote. So what does that tell us? Well, that tells us that the graph cannot do something like this. Why not? It's respecting the boundary. It's under the boundary, and this is positive, but it's not positive the whole time. In order to come from down here, it has to come from the negative, which is not allowed. This chart clearly says that until -2, we should be strictly positive. So therefore, this line is no good, and we're going to have to do something more like this. Now, if you want to find some exact values, feel free. You don't have to. I'm not going to make you do that. You can plug in numbers like x equals -3 or x equals -4 or x equals -10 or whatever you want to plug in. You can plug those numbers into the original function and see what you get if you want a more accurate picture. Okay, so we have that the function is positive and then goes to an asymptote at -2. Then let's look at the chart to see what happens here. Then we should have a negative, so it comes from below. That's like down here, yeah, coming from below, good. Then it hits the 0, then it goes positive for a little while. We don't know how high it actually goes. It's possible that it goes higher than the 1/2, right? Like it's possible that it goes up here and then drops down. Who knows? We don't really know. And then it goes positive, hits the 0 at 1 plus square root 17 over 4. So here's where we're at now. It's positive, and then it's 0. Then it goes negative and goes to the asymptote. So it looks like the instinct was correct to make it go down, 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 down. And then the asymptote comes, and then we have positive values. So after x equals 2, it's all strictly positive. So for the same reason as the left side, this is going to have to be coming from the top and going outward like that. Okay, so here's a perfectly good sketch. Perfectly good sketch. Now let's answer questions G and H. It's kind of hard to see it. I'm going to rewrite it here. G says the limit, which you might not have seen yet, as x arrow infinity, as x goes to infinity. So what are we looking for? What does limit mean? Limit means that we're going to try to determine the y value, or at least where it seems the y value is going towards. And this notation on the bottom tells us where we should be looking at from left to right. Got that? So one more time. The f of x is the actual y value that we're looking for. This just tells us when, or sort of where specifically we should be looking, left to right. So it says x goes to infinity. How do I go x to infinity? How do I send x to infinity on a graph? I basically just look all the way to the right, because the number line is going to keep extending this way. It's going to go towards infinity. So they're basically asking us what happens to the function when x is going out towards infinity. So if we follow this roller coaster, if we ride the roller coaster, we know that there's a boundary of 2. So that is the limit. In fact, this is the exact same thing as the horizontal asymptote. It's basically the same thing. We're asking what happens if we make the x value really, really large. So this is just going to be 2. I guess you can say y equals 2 if you want. Now let's look at h. H is also a limit, but it's worded a little bit differently. This says the limit as x goes to, careful with this, as x goes to minus 2. I know it's blurry, so if you can't see it very well, that's okay. I'll write it out for you. As x goes to minus 2, so we need to go to negative 2. X needs to go to negative 2. And there's a little other thing on here, but I'm going to take a second first. X goes to negative 2. Well, if I'm on this graph, how can I get to x equals negative 2? I could go from the right, and if x goes to negative 2, I have to follow the function, so I can't just like go straight to the negative 2 and say, hey, I'm here. Here I am. I'm on 0. No. We're talking about on the function. It's a limit of the function f of x. So we still need to ride the track. We still need to ride the roller coaster that is drawn, which is the graph. So we need to ride the roller coaster, but get closer to x equals negative 2. It doesn't have to go to that 0 point, just has to go to this line of negative 2. What happens as I get closer to negative 2? Well, this thing goes down, 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 down. I start to go to infinity, but it's negative. I start to go to negative infinity. But what if I don't want to come to negative 2 from the right side? What if I want to come from the left side? Well, if I'm going to negative 2 from the left side, I'm going to be using this piece, which goes up to positive infinity. So which one is it? The left and the right sides do not agree. And now I'll explain what else is on this. This little symbol that you probably can't really tell, this is a plus sign. And what this plus sign indicates is it indicates to sort of ride the function, ride the track, or ride the roller coaster, but from the positive side, aka the right side. I guess I'll just say the right. Let's extend that a little bit. There we go. So we're looking for the track on the right side, not on the left side. That means we're looking for this part that goes downwards right here. Yeah, like if someone's falling down a well, right? Like the evil villain falling off a cliff. Like they're going down, they're going down, they're going down, they're going down to negative infinity. So that is what the limit of the function as x goes to -2 from the right is. It is negative infinity. Now, it's sort of tough to say that a limit is equal to negative infinity or equal to positive infinity. For technical higher level reasons, we don't always say equals. But anyways, for now, I think at this level, it's totally fine. The point is, where's the function going on the right? That's really what we want to interpret this as. Okay, so that was a brief video because we only talked about one problem, but we broke it down very carefully. I want you to understand this skill, whether you're in Algebra 2, whether you're in pre-calculus, or whether you're in calculus. Even if you just suffered through this topic in Algebra 2, maybe like first semester or something like that, I still want you to revisit it, because if you plan on doing any more math at all at a high school or even a community college or even a university level, depending what level you're at, there's going to be this kind of question involved, and it really doesn't hurt to be able to do it by hand. We have technology now that you can use. Of course, you can throw this into Desmos and get all the information you need about the graph, but I think that's a bit lazy. I'm really encouraging you to do the work. Don't simply just watch the video and be like, yeah, that makes sense. Yeah, that makes sense. I want you to actually do the work if you need the practice. Okay, that'll do it for today. Going back into the void until next time. See ya.